Thank you everybody for coming on today, whether it be morning as it is for me in Seattle, or whether it be afternoon or even evening in other parts of the world. First of all, today we're going to kind of talk about a story from most of our not so recent past. Most of us remember the global financial crisis and the bailouts that we had to do in the United States to save, effectively save the economy from going into depression. And effectively what we did as taxpayers mostly supported a lot of big institutions. Why did we have to do that? Because they got too big to fail. Too big to fail was a big problem in our overall system. How did this happen? We started with large bets, big amounts of money, usually other people's money, so the people that were doing the investments weren't investing their own money, they were investing other people's money, in a manner that failure, so, even a little bit of movement on an underlying, piece of property would cause a large movement in a derivative, would blow up the entire financial system. This is what we lived through in 2007 and 2008 when we were staring into the abyss of potentially a depression. It was a very scary thing. This is not just a problem for global financial systems. This is a problem for any kind of system that involves people making lots of bets with other people's money. It matters for software projects as well. People make large bets, sometimes hundreds of millions, sometimes even billions of dollars on software. It's amazing how big some of these projects can get. Often, almost always using other people's money, especially when you go farther up the chain of very large software projects. Failure, which is more likely in large projects, and we've all seen projects go for 2, 3, 4, 5 years and don't release anything. Failure, the longer you go, is more likely to occur, leads to calamitous consequences for the entire system in which the project is hosted, including going out of business in some cases. How do we get there? How does this happen where we're allowed to get too big to fail? So let's say we start with some good intentions. Let's get rid of the mainframe, some crazy idea like that. We add in some hopeful estimation, some kind of trying to make sure we have a can-do attitude, but at the same time making a lot of assumptions that may not turn out to be true. And then you throw in there, you hire an architect or you hire some technical people that may want to do something we like to call resume-driven development, where you just want to use some technologies that are new and interesting to you, but somehow apply them to a large organization, or any number of other ways that we can inject something that will kind of make it more likely that we'll fail, inject more risk into the system. We then get to, at some point, a reality gap emerges. Murphy's Law sets in. Everything that can go wrong will go wrong. When those things happen, we get demands for pragmatism, kind of a nice way of saying cutting corners. We usually kick out the user experience first. I mean, who cares about that? That's just colors and stuff, right? And then, eventually this kind of corner cutting starts to make morale drop, and, engagement goes down, productivity goes down, politics really emerge in the product, and it just becomes a negative thing. So what can happen after two? Usually there's two phases you can go. You can make the project die, or you can significantly pivot it or try to do something different. That's probably a better outcome. Or what's more likely, unfortunately, is you actually get more money. This is what I call the money bomb phase. We start to throw lots of good money after bad. We decide we're going to persevere despite all the evidence looking us in the face, and suddenly our team of 30 has become a team of 150. It gets larger and larger, more complex, and starts to become much more of a disaster, frankly. Stage 4, after the money bomb, is the predictable bozo explosion. Bozo the clown. You start having lots of people in the organization, multiple layers of the organization. You start to get some of these fabulous people that just go from meeting to meeting and don't really contribute anything. And the real core talent, the people that initially envisioned this thing and had a good sense for what this thing was supposed to do, they start leaving the company. And it starts to become pretty evident to a lot of people that there's some real problems. Usually at this point, the VP that started sponsoring the whole thing at the beginning, they're starting to call headhunters. Things are starting to go really bad. The last phase of this is what we call Judgment Day. Judgment Day usually occurs either the company runs out of money, that'd be bad, or more likely, somebody like the CFO has to explain it on the conference call on Wall Street or Bay Street or wherever your financial institutions are, and say, listen, our spend went up, we didn't have results, but we're going to do some acquisition or some other thing that they have to explain away. Usually once it gets to that level, the CEO and the CFO have had to answer a lot of hard questions. Somebody's getting fired, and it's usually the sponsor of the project. Ultimately, the project gets scrapped, and the only asset, a value that comes out of this is the asset as being a corporate write-off you can use against your taxes because you lost so much money. This is the problem of too big to fail. I can't underscore this enough, huge problem in corporate IT. The good news is most companies kind of survive. I mean, usually before you run out of money, somebody's going to stop the line. But it really sets companies back. I mean, you can't just lose $250 million out of your, even in a large company, even in some of the largest companies, and not have to recover from that over a number of years. Just the raw financial cost can be a serious setback. The burden can take years to eliminate, but worse, and this is probably the biggest problem with these kinds of projects, is that they remove any kind of risk tolerance or any kind of tolerance for trying new things after the big disaster occurs. Sometimes this can set a company back 10 years where they don't want to try anything new and bold because they just got their hand burnt trying it the last time, spending all this money and getting absolutely no results from it other than a big loss. I have an article I've written on this, is.gd/learn-to-fail, if you want to look at this in more detail. So, but really, kind of what's our advice for avoiding this state of affairs? How do we avoid getting too big to fail? And that is fail faster. Fail before you become too large. Failing early costs a lot less than failing late. Failing early means you recognize something's not going to work, or you recognize something needs to be different, and you make a serious pivot. You make a real executive decision back here rather than waiting right there. Why fail at all? I mean, it kind of sounds like a dumb idea. Why would we think about failing as a goal? That sounds like a scary thing. Why don't we just do it right the first time and succeed and make a good plan so we can have a good product at the end of the process? Well, this is the thing. Innovation means trying new things, trying risky things, trying things that you don't know for sure will work. So, they may not work. The key is to fail fast and learn before you spend all your money throwing good money after bad. If nothing else, I mean, this is kind of personal for a lot of people. You get engaged in this thing, you don't want to see something fail. But if you can do it early, you don't risk all your political capital versus waiting, having to go to the bank, get the big funding, get $10 million of funding, and then have somebody tell you this is better work or else it's your job on the line. If you can do the experiment in a much lower time scale, you don't have to risk all your political capital. So this isn't just a fad. This is backed by science. I know it sounds kind of scary, but this is actually kind of something that we've done for years, something that we've done for centuries, frankly. Here's a scientific method. Scientific method. Define a question, gather information, form a hypothesis, test the hypothesis, analyze results, draw conclusions, publish results, and retest. This isn't a fad. This has been around since time immemorial. Now, one of the things you'll notice in the scientific method is that 5/8 of the steps of the scientific method are about testing our hypothesis and doing something with it. That's a really important thing to remember. The scientific method is all about testing. It's 3/5 ideation and creating your hypothesis, 5/8 actually testing that and making sure that it's right. Continuous delivery is, frankly, the application of the scientific method to software development. That's all it is. When you get down to it, it's really quite simple. Now, let's look at this in terms developers understand. So we started with this idea that we have the scientific method, the same 7 steps here. 8 steps, sorry. Software development, kind of similar. Get a new requirement, that's kind of the question part, gather details, write the story, test code, refactor test. Those are kind of the steps around kind of creating the thing. But then the rest of the steps are around actually testing it, acceptance testing, performance testing, pushing it to production. And then most importantly, this kind of last step before you get to new requirement again, analyzing user behavior. Once we go to production, that doesn't mean we're done. It means that we need to actually see whether the thing gets the business results that we're trying to achieve. That's the key thing here with continuous delivery. So that brings us to the next concept, which is what is a lean startup? Because Lean Startup is this great book by Eric Ries, has a lot of really great ideas, and it's utterly linked to continuous delivery. But let's look at what the lean startup is. It is the creation of rapid prototypes. Okay, we need to get to something that we can actually test very, very quickly. It's designed to test market assumptions. So when we start building a product, or we start building an internal system, we have some assumptions about what it's going to do, how productive it's going to make your people on the floor, how much it will sell, how much it will convert into real sales of your product. All sorts of assumptions that every ROI document that somebody's ever tried to make have built into them. Well, instead of just assuming that the ROI works out, why don't we actually test that stuff as early as possible so we can actually make decisions based on data, not make decisions based on opinion. We do that using customer feedback, user feedback, to evolve the product much faster than you would with traditional product development practices. So if you're waiting a year to get your first version out, then you're waiting a year to get version 1.1 out, which is kind of traditional product development practice, you don't have many opportunities to try something new. And that's something that we want to get away from. So what are the key concepts in a lean startup? There's really kind of 5 core things. The first one, we're going to talk about this quite a bit, is the minimum viable product, the MVP as we like to call it. The second one is this concept of validated learning that has a lot to do with the analytics end of this, actually taking what we've done in production, learning from that, and using that to form the next question or what should be the next action in our cycle of continuous delivery. The concept of continuous delivery. Lean startup, the engine behind a lean startup is, in fact, continuous delivery, what we've been talking about in this entire webinar series. Meaningful analytics. That's kind of the engine of validated learning. There's a lot of ways you can analyze. There's a lot of data that you have, but when you're doing lean startups, you actually have to have actionable data, not what we call kind of vanity metrics, which might measure something, but they don't measure something relevant to the business goals that we're trying to achieve. And lastly, pivot or persevere. This is a key concept from lean startup. At some point you reach a conclusion, and that means you might need to do a new kind of MVP to take the product in a different direction or orient it towards a new market, new kind of set of users, or some other major change in direction. We accommodate that in the lean startup by having this concept of pivot that we'll talk about today. So first, what's a minimum viable product? Well, first of all, it's minimum, okay? That's a key concept here. I've seen lots of minimum viable products that are 80% of what somebody envisioned, okay? That's not a minimum viable product. It needs to be small so you can gather feedback very, very early. Ideally, I like to have a minimum viable product that can be built in 30 to 60 days, if possible, so we can very, very quickly start getting feedback and base the rest of the product on data rather than somebody's opinion. It doesn't have to come from everybody. You don't have to do a big splash for the minimum viable product. One of the first things that people will say is, well, what happens if this goes out to everybody? That's not necessarily something you have to do. If you already have a big brand, like a lot of people do, what you may want to do is do something under a different brand to establish that the product works before you link it to your brand. The key is get relevant feedback based on the product. Viable. Okay, so this is a concept where you can't just build the login form and call that the minimum viable product. So this is a concept that's kind of in contention with minimum. And that's kind of the balancing act you have to do in prioritization, is make it as small as possible, but still make it a viable product. It has to be something that people will get utility out of, which gets to the next piece, which is a product. It has to be a cohesive set of functionality, not just a scattered set of features that are kind of halfway done. The features that you do choose to put into a minimum viable product have to work really well for their end user. It has to be a product that is something useful that a customer will get value from. How do you define one of these things? So a lot of people say, does this mean I just have to make a half-baked product? Absolutely not. In fact, one of the biggest things that I always recommend people do is think about when you initially start envisioning this thing, be as bold as possible. Put every idea on the table. You might have 300 ideas for what ought to go in your product. Absolutely. My recommendation is for the first 2 weeks or for the first month, have an envision period where you imagine what this thing is going to be. Capture the imagination of the people that are on your teams that are going to actually have to build this thing. There's absolutely nothing wrong with having a big, bold vision of a big product. I'm absolutely okay with that. However, once you do that for two weeks, maybe 3 weeks, something like that, you absolutely have to distill that product vision into stories. And not just kind of stories that are, make this a database call somewhere or something like that. We want Agile style stories that have real user value. As a blank, some kind of user, I want to have some feature in order to achieve some business goal, written out precisely like that. We want to distill this product vision into a list of stories that we can then go in and prioritize. Ruthlessly prioritize the list of stories. Have maybe 5 or 6 levels of prioritization if you can. Throw out some of the ideas that don't turn out to be very good at all, or at least backlog them. But then find some cohesive, minimal viable product that is your top priority of stories that will allow you to start getting feedback as soon as you possibly can. That's really the goal here. The thing that you don't want to do is try to please everyone with your MVP. There's a lot of people who come out, we need to do an MVP, but it needs to be a big launch and it has to please a large group of users. Absolutely don't try to do that. The key to an MVP is making sure you choose a very specific kind of user segment that's representative of the market you want to approach, and make sure you do a good job for that particular segment. If you can start with that smaller number of users, iterate a smaller product, and then scale out as you gather evidence, that's a much better approach. Please, please don't try to please everybody with your MVP. So some questions that you'll get when you're defining an MVP. Sort of clarifying questions as you're trying to build this out. If the product had to do one thing, and only one thing, what would that be? Okay, that's just really a key thing. What is the essential thing that makes this product a product, or makes this tool useful, or makes this thing productive? What is that one thing? What would happen with version 0.1, kind of our initial MVP, that had no settings at all? Everybody's seen these apps that have big, complex setting screens for every kind of different thing that a user might want to do. I'm a big fan of not having any of those, just having some really smart defaults that kind of take you down the most likely path of usefulness for a customer. This is where you use the 80-20 rule to figure out what are just the things that we need to do. And it makes you kind of think about smart defaults. One of the keys to these kinds of pieces of software is they anticipate what you want to do. Maybe they don't let you change things at first that might specify exactly how an application works. Lastly, just think. Someday we'll want to take over the world, but where do we start? What is our first target customer archetype? And we might say, if we're trying to do some new kind of .com app or something like that that's kind of consumer-oriented, we might say we want adult females aged 35 to 44. Have that persona in mind and kind of orient the product towards them, and maybe they'll be influential and can get it out to other people. But if you can kind of focus on a particular demographic, it's a good way to kind of limit what your product's going to do and focus your efforts that way. Typical objections that we get to this, and we've been doing this stuff for a while, and trying to sell the concept of MVP, you often run into, I don't want to launch a half-baked bad product. So how do we handle that objection? Well, first of all, what's the alternative? The alternative is you build some big product. And as we know, the risk is much higher when you have to go to the CFO and say, give me $10 million to build version 1. You're, like we said before, too big to fail. You have all your political risk in the organization based on this one thing actually working. So that's the problem. The bigger your minimal viable product, if it starts to become a maximum viable product, you have to take your risk is a lot higher. I think it's much higher doing that than just launching a product that isn't perfect, that doesn't handle every single case that you want to handle. The other thing is hubristic impulse, this idea that I am automatically an expert at this product. I know my customers so well that they better than they know themselves. There are people that will become overly confident about what they believe the product is or what they believe will work in the product. That's something that you need to kind of avoid as you're kind of handling this. And just the key thing to remember, and I'm going to stress this again, big products require big projects, require big budgets, require big promises, require big servers, require big governance, and are prone to becoming too big to fail. They're prone to becoming these things that can literally, if they go bad enough, either destroy companies or really, really burden them going forward. The last point I'll make on this is that you are not Steve Jobs. I take that back. Maybe you are Steve Jobs. Maybe you are that brilliant product designer who always gets it right the first time and doesn't need to learn anything from their client base before they make their changes. A little secret, even Steve Jobs wasn't Steve Jobs in that sense, from that sense. Even Steve Jobs had to, iterate over products. The first iPhone wasn't perfect. It was a longer product cycle than we recommend necessarily. But, the key is, just like everybody, not every person's going to go into the NFL that's in high school football. Most people might be very good at product design, but they're probably not that genius that gets it right the first time on a one-year cycle. We think it's probably safer to do this lean startup methodology. The other objection that we get to something like this is the annual budget objection, whether, this can't work. How can we do this and decide things, not have fixed scope and fixed budget? So let's kind of go through those two things. We have fixed annual budgeting, we have evidence-based funding, which is what I like to call the alternative to kind of fixed annual budgeting, as you might see in a lot of organizations. In fixed annual budgeting, the budget promises both scope and spend, usually unreliably. Evidence-based funding, by contrast, budget covers spend, scope changes based on business need and or evidence. Now, at first, you'll get some pushback. I want to know what I'm getting for my money, right? What I would say here to help work against this as you start getting people to buy into this methodology is right up front say, listen, we'll cut the budget by 10%. If you give us flexibility to do the things that we need to do and make the decisions we need to make as we go through this process and allow us to pivot if we have evidence that we need to pivot at some point. Tight change order process. That's something that's fairly common in fixed annual budgeting. Usually you need kind of an active, somebody really important in the company in order to get a change order done. I mean, this is literally it's trying to control for having too many changes happen. There's this term called change management. We need a big heavyweight process over changes that could come into the system. And we want to make it really hard to make changes. That to me almost is silly. I mean, if we find evidence that something doesn't work, why would we want to make a heavyweight process that requires 7 levels of approval in order to make changes at that point? It almost kind of seems like the reverse of what we want to do, which is make it easier to make those changes, embrace those changes as we learn things, and allow us to do real-time resource allocation based on performance of different projects or different people or different, frankly, business performances of different areas of the software. Third problem with this, new ideas have to wait till the next budget cycle. Now, that's not always true. You might be able to get the CEO to say, you know what, we're going to change the budget and change some things around. But it's usually for new ideas to not come in off the budget cycle is a hard thing to make happen. With evidence-based funding, you get the ability to capitalize on new opportunities that emerge. That's a really important thing. Is that sometimes we're going to learn things, and sometimes we're going to know we need to pivot to a larger customer group or something like that. We need to be able to actually capitalize on those opportunities. And so again, evidence will draw funding, not the other way around. The last thing, and this is kind of one of those scary things, probably everybody has seen this idea of a zombie project. So it's something that's funded. It's something that we know isn't going to see the light of day, but because there's still budget for it, it still keeps going. And they're allowed to consume resources even when failure is pretty much known, it's imminent, but it keeps going anyway. We want to avoid zombie projects, and we do that by having the flexibility to kill failing projects with a minimum of ceremony. That's one of my favorite things about evidence-based funding is it doesn't lock us in. It allows us to stop doing things that are dumb and start doing things that are better when evidence comes in that the former is actually occurring. So that's the MVP. Validated learning. What is this idea of validated learning? So let's think about this. What is more important? Maximizing revenue or maximizing what you learn about how you sustain profit? This is a quote from Eric Ries, author of Lean Startup. Startups exist not to make stuff, make money, or serve customers. Again, I'm going to say that again. Startups exist not to make stuff, make money, or serve customers. They exist to learn how to build a sustainable business. This learning can be validated scientifically by running experiments that allow us to test each element of our vision. That is kind of a radical idea. Startups don't exist to make money. They exist, but it's a really good idea, actually, as it turns out. Because if you have this, we're just going to maximize revenue, there's an entirely different strategy if you're trying to build sustainable revenue. And the Big Bang approach, which is let's just try to maximize revenue, what we're going to try to do is guess a path to profit, try to build a product, and sell the thing by brute force. We might cut a deal with a telecom to make our app, like this undeletable app that forces everybody to use it. We might get one big push of revenue, but in the process, alienate all our users. Or you can do validated learning. Instead of doing that, let's just prove a path to profit based on our target customer and then scale it out. Okay, so this becomes just, figure out a way to make it profitable in the small, what we call ramen profitable, and then scale out the idea once we know that it works. Big bang, high risk, high reward. There's a big risk, as we kind of covered before, that the thing won't work. But if it does work, yeah, it could work out really well. It could be the next iPhone. Validated learning still has that same high reward. But what you're going to do is you're going to take a much more conservative approach to get there. You're going to take lower risk. You're going to risk less initial capital at first. You're going to get to sustainability, and then you're going to organically grow that over time. The project sponsor. Let's think about what the person that's heading this thing has to do. In the Big Bang strategy, what they're often doing, and probably you remember this from the startup days, where you had a startup CEO and he spent 90% of their time going to different venture capitalists begging for more money, or going to different customers begging them, some big money customer, to spend $1 million on a software license somewhere. That was almost exclusively what CEOs did in the dot-com era. If you've ever seen the movie Startup.com, it's a really visceral demonstration of this factor in action. Validated learning, on the other hand, we choose a different focus for the person that runs the startup, runs the project, runs the program. The project sponsor focus is choosing the correct customer segment, thinking about who their users need to be, figuring out a way to scale the revenue based on those users, and then figuring out, based on the information coming in and based on the analytics coming in, when do you pivot? It's a radical notion, that the sponsor can actually focus on the product versus focusing on just getting the next round of funding. So what does this have to do with continuous delivery? Continuous delivery is, simply put, the engine of the operating system of a lean startup. We can have a car dashboard that measures exactly how this works. You have an RPM. That's the frequency at which you can deliver to production. You have the speed. It's controlled by the RPM. Frequent testing means faster velocity, so long as some other conditions are present. Temperature. Are you doing too much at the same time? What is the level of work in progress that you're trying to do? If you go too high, it can start to cause problems. And fuel. Do you have enough funding to become self-sustaining? Let's dive into this a little bit. So the RPM. What drives the number of assumptions that you can test in a week? Time between code and production. This is one of the things that whenever we do an assessment for continuous delivery readiness, we look at how much time lag is there between when a programmer writes some code and that code actually goes out to a production system. Okay, I've seen cases where it is a day, and I've seen cases where it's 5 years. The lag can be incredible between different kinds of organizations. There's a lot of organizations that insist on putting a lot of roadblocks before you get to production and multiple gates. We kind of believe that most of those roadblocks tend to hurt your ability to continuously deliver rather than help. Efficiency of analysis. How quickly can you take what users are doing on a production system and actually learn things from that? So that's really kind of after you've gone to production, how fast is that lag between going to production and actually understand how users use the product? Some companies don't do any analytics at all. Some have very detailed analytics that are very meaningful. For example, most people that sell things on the internet very frequently measure conversion. How often does somebody visiting a product page actually go and buy that product? The key is how quickly can you measure results. That will control your RPM. Time from idea to code. How long do ideas sit in management before engineering gets to work on them? Sometimes it's a cross-functional group and everybody does this very quickly. Sometimes these are two VPs in different companies and they don't talk very much at all, and these ideas leak through maybe once every 6 months in some memo somewhere. So there's a very radical variation between companies on this metric. Speed of continuous delivery. Now, how fast can you actually drive your business goals forward? Now, this is controlled by RPM, what we previously talked about. The higher your RPM, the more you can potentially advance your goals. I say potentially here because it's also governed by the effectiveness of your metrics. Think of your metrics. RPM kind of controls the speed of the engine. Your metrics are your transmission. If you have bad metrics, it's like trying to drive with a high RPM, but you're in first gear on your car. So you're really revving your engine, but you're not going very fast because it's not effective metrics. Are you measuring the right things? If you're measuring the right things, you might be going straight up into sixth gear. Prior optimization. Now, one of the other things that could happen is that you've been doing continuous delivery on the same customer segment for a very long period of time, and you make it to some point where you've already optimized for a given customer. Maybe it's time to pivot. Okay, and we'll talk about pivots where maybe you've already optimized for a given customer segment. Maybe you need to try some different customer segments. This usually happens as one of these kind of initiatives starts to mature a little bit. Temperature. What drives your level of work in progress? It's a general contention that we want to try to have the least amount of work in progress that we can get away with. The size of your MVP. The larger your MVP is, the more you'll try to likely do too much at once. Okay, so we want to make sure we constrain the MVP to do as little as possible given the other constraints that we have. Now, this will be in contention because sometimes you need to be running a lot of experiments at the same time, and you'll increase your work in progress. But absent other concerns, you want to lower this to as little as possible to focus on the 2 or 3 things that are most important in your product development efforts. Efficiency of analysis. Now, this gets into the lag. So if you have a long time between when you start an idea and when you get to production, the longer that lag is, the less frequently you're delivering, the more overlap you're going to have. When you have more overlap, you ultimately have more work in progress because we have a very aggressive definition very conservative definition of done that we'll talk about in a little bit. Lastly, time from idea to cash. And this kind of takes these 2 things together. How long does the idea sit in product management before engineering gets to work on them? Again, it's about the entire pipeline. Fuel level. What drives our ability to finish something before we run out of money? Well, size of the MVP again. If we have a very large product, we probably have to get it exactly right and we won't have any ability to pivot. Larger your MVP, the fewer chances you have to pivot before your money runs out. Value the idea. Some ideas are just dumb, or some ideas might be really, really hard to execute given current market conditions, or the technology may be too early, or a number of other things. But some ideas are just bound not to work. And then, of course, burn rate. I mean, this is stuff we learned, back in the .com era, and just kind of basic economics. If you go out and buy Porsches for everybody, and just spend your money unwisely, and don't focus on the product, you'll likely have a very high burn rate, and that'll cause you to not have as much fuel as you ought to have to actually get this thing done. So now, analytics. So there's a statement here: production doesn't mean done. Now, to a lot of people, just checking the code into a source code control repository, to the developer, sometimes they say, "I'm done." Okay, then they'll say, "Wait a second, that's not done. We haven't even had QA look at this." So then we decided that once QA actually validated that the software presumably works, we started saying that was done. And in a lot of organizations, that is really what means done. Then we decided to change that and say, well, there's this kind of big problem with the last mile. So something can be done in QA, tested on a test server, but getting from there into production is really hard. We have to make sure the performance works, and a lot of other things are ready for production. So maybe production means done. And so that's an aggressive definition that we've been using for a while. Sorry, we're going to change this again on you. Now we're going to say production doesn't even mean done. Production doesn't even mean done, which it sounds crazy. So what means done? Being done means the goals of the actual change have been achieved. Okay, just putting stuff into production doesn't mean you've achieved your business goal. Your business goal means you want to actually do something with the software that makes you money or makes the world a better place or has some other goal. It's not just about putting software into production. Now, it needs to be done in a way that we can objectively measure. So if you're using vanity metrics, you're not going to really know whether you achieved your business goals. So we have to be able to objectively measure them. Now, if the change doesn't achieve the goal, we can back out the change and try something else. Maybe we put the change into production, we find out it sent our conversion down by 5%, and it's actually hurting us. So we can undo that change and try something else. But really kind of the most important thing to understand here is just going to production isn't sufficient. It's not until you achieve real business results, real positive business results, that we really consider a given story done. And that's a radical definition for a lot of people. But I think it's one of the most important definitions we can have. Analytics, useful versus vanity. Some of you may recall, back 15 years ago, that we had this measure for a startup's value, which was eyeballs per share. I don't know how many people in the audience remember eyeballs per share, but in 1999, people would go on CNBC and seriously talk about eyeballs per share. I can't think of a dumber thing in retrospect, and we all got caught up into it, so I'm not really complaining, but that was one of the most vanity metrics I can think of. Other things, without further context, bounce rate, abandon rate, maybe they're people you don't want. Maybe you want them to abandon if they're not the kind of user that's actually going to buy from you. Maybe they're just eating up bandwidth and not actually being useful. Users, again, kind of another version of that. If we have a lot of bad traffic that isn't useful or just a lot of search engines hitting us but no other actual users, maybe that's not something we want either. Measuring raw page views is another kind of case of this. Now, contrast. Useful metrics actually try to measure something that has some meaning from a business goal perspective. So we can measure profit margin per customer transaction. Okay, that's a useful metric, especially if we combine that with a conversion metric, like a conversion of AdWord traffic into customer sales. So that paired with the prior one would be if you're selling stuff on the internet, probably one of the ways that you're probably going to measure how effective you are. If you're trying to build a social network, effectiveness of a given viral loop in bringing in new profitable users. Again, some of the same things apply. Has to be related to your business goals. It can't just be something in isolation. What are some techniques we use to do these analytics? Kind of typical techniques, A/B, split testing. There's a couple ways you can do this. You can do kind of a before-after test after you go to production. How does the thing change? But more importantly, probably one of the better ways to do this is if you have a farm of servers, say you have 10 servers serving up your website, you might be able to say, take 2 of the servers and measure the change on those 2 independently of the other 8 and see how user behavior differs between one and the other, isolating for time. Okay, that's one of the key techniques that we use. Test the effect of a single change. Cohort testing goes a level deeper. Particularly, this is relevant if you've gone from one customer segment and expanded to a different customer segment. You may try to test across those 2 different customer segments and see how their behavior differs. To see if after you pivot, has it been an effective pivot? Have you alienated your old users versus your new users? Questions like that. The next one, multivariate testing, often done quite a bit further into a startup's life or a project's life or a program's life. We're trying to measure these things. Multivariate testing says we're going to do A, B, C, D, E, F testing. As you can imagine, the more variables you add, the larger your matrix of possibilities becomes, and the more complex it is to actually test something like that. So we don't recommend this until you've got a lot of traffic and you've got a pretty good infrastructure that can do effective multivariate testing. So that's the concept of analytics. Pivots. Is it time to make major changes? Time to pivot. The question is often, do we pivot or do we persevere? Do we keep going on this path? There's a lot of different kinds of pivots you can attempt to do. You can do the customer segment pivot. You found out a different set of users use your product than the ones you envisioned. Maybe you should start orienting new product ideas towards that actual set of customers that uses it. So imagine something comes out and your target metric is men 30 to 34. You put the product out there and it has a feature that, as it turns out, it's really women 50 to 58 that use the product. So maybe you orient yourself towards that segment and start kind of optimizing your product towards that versus the original one if it turns out that the users you attract are different than the ones you envisioned. Value capture. Maybe what happened was you had a great product, lots of people use it, but you're not making any money. So say you did like a freemium site. So parts of it are free, parts of it are you pay to use them, and everybody's using the free stuff. So maybe you need to pivot and figure out a different way to monetize those customers that you already have. Technology pivot. This might be something where you build something on an initial platform that may be very fast, may not be particularly performant. Maybe after some point you decide to do a technology pivot and use a different platform. So allegedly this is what happened at a company like Twitter, or at Twitter, where they initially had one technology platform and then they decided for whatever reason that performance characteristics of the server needed to change to have enough traffic, and so they changed to some certain different technologies at that point. You have your zoom in and zoom out pivots. Zoom in pivots are when one feature turns out to have all the value, you restructure the product to focus on that particular feature. So as you're measuring usage, you find out that the 20% of the product that's actually useful so you focus on that. Zoom out goes the other direction. You build a very small product, and as it turns out, you might actually have made the MVP too small, and you find out that product would be, it'd be a better product if you added a couple other features that are complementary to your initial one. So you could actually find that out. You could actually go in and find out that you did too small of an MVP. And there's many others, and I would refer everybody to the Lean Startup book. There's a whole chapter on different kinds of pivots that you can do. So that's great. We have some supporting concepts here as well. First thing is getting the culture right. So this is just kind of a cultural thing you want to do in any group that you're trying to execute this idea with. You want people to have curiosity over having confidence. I underlined the word con on purpose. So curiosity is this sense of when I go into my efforts, I immediately understand that this may or may not work. I'm curious about what this thing is going to do when it hits its market. Willingness to admit mistakes. This is a second kind of a piece of this, is that a lot of people find it very hard to admit that they were wrong. That's some of my favorite words in the English language are, I don't know, and I was wrong. That just kind of, not only does it leave a little bit of vulnerability, but more importantly, it allows an effective decision to be made. If you're insisting that you're right, even and persevering on how right you are most of the time, and you're not, that just leads you in a very bad direction. Orientation towards being driven by data over opinion. This kind of goes with this, and that is, if you have good, meaningful analytics, data will control whether you're right or not. It's not the power personality of the sponsor or the given person that had that great product idea. If the data shows it doesn't work, okay, we admit it doesn't work and we move on to the next thing. Bias towards short-term optimization, against short-term optimization. This is, again, what you're going to get is that kind of, with somebody that's super short-term optimized, they just want to sell this thing to as many people as possible, get it out to a lot of users, even if they're not profitable users, and then flip this thing at some point to some other investor, or initially get some big success on some internal product, but then not care if it actually sustains itself. Kind of what I call lots of people have seen these knowledge management systems come out with a big splash. Everybody looks at it at first for the first 3 or 4 days. The metrics look really, really great, and then usage of it drastically tails off as you get towards the end. What we want to do is create a bias against that kind of thing. Think about sustainability more than we think about just rapidly increasing the revenue number at first. And then kind of no jerks, no dictators. I mean, this kind of goes along with this. If you have those kinds of people, they tend to have a lot of the attributes that make the culture really hard to execute this methodology. Delivery climate. Engagement at every level, not just happiness. It's really easy to make people happy. I can buy a pool table and put beer in the office and say that you come in at 10 o'clock and you can leave at 2. And I would have a bunch of very happy coworkers. I probably wouldn't have a very engaged workforce, though, because they're not actually getting much done. They're just kind of hanging out and having a good time. A big difference. Engagement means we're going above and beyond, crawling over hot coals to actually make the product work. There's a big centricity around the mission that we're trying to get done. There's fanatical support for the goals and principles around our work. That's what we want from engagement. We have deep care and kind of goes along with this, but deep care and concern about the person that actually uses our software. A lot of people in this audience may have used time tracking systems in the company you work for. And I'll bet you, if I had to ask, how many of you actually find it to be an enjoyable user experience using that time tracking system? I think I'd probably get maybe 1 or 2 hands up, and those would probably be from people that actually built their own time tracking system. Nobody likes these things. Why? Because the person that buys the software is different from the person that uses the software. And to get this right, we have to actually have a delivery climate where the people writing the software have an intimate connection with the users that use the software. The more that we have that there, the more that we're going to build things that users actually want to use and then actually measure how they use it to actually improve the product. It's a key concept. Quality orientation. This is another thing that's important. What we want from our engineers on our team are people that keep the code clean. We want them to push back and be revolted by the idea that we'll cut corners here and there in code quality so that we can make some artificial date. We don't want shortcuts in engineering. What that will do is it will become almost like a cancer in your code base that will become larger and larger and create some real problems. We want a team that has fun, celebrates wins, even micro accomplishments throughout the day. One of the great things about lean startup and continuous delivery is that when you're delivering software, sometimes 7, 8 times a day as they do on Flickr, as they do on many other startups, you get accomplishment throughout the day. You went to production multiple times a day. It increases the level of engagement when you actually have this cadence of constantly getting things done and constantly getting things out there that are useful to people. People love to work that way. It's a fantastic thing. Engineering quality. This is a core fundamental concept. No broken windows. We absolutely need to make sure that we keep the code clean and just make it great. If we start having broken windows in our code, people will start cutting and pasting where we took the shortcut, and then suddenly your code will be a big, big mess. And we want to avoid that because what happens is in any Agile methodology, the ability to make changes late is dependent on having clean code that makes those changes easier to make. If you have a big mess, changes take a long time, and you start resembling any other waterfall project just because it's so hard to do work on your product. 100% test coverage from the start, design for testability. If you're going to have no broken windows, that means you design for testability. This is not something we can compromise on. Business readable code. Now, I don't expect business users to write code. That's kind of what the engineer is for, and I'm perfectly okay with that. But I certainly think if you write code and you're doing it correctly, especially in a part where there's an algorithm that has business logic in it, business users should be able to read that. They should be able to look at the code and validate it. Yep, that's the formula for calculating sales tax in Alaska or whatever, and that should just work. As much complexity as you need, but no more. If you start seeing factories and all sorts of other just kind of big constructs that some architecty type will put in, but you don't actually need, that actually creates artificial complexity, makes the engineering harder to work with. You want to avoid that as much as possible. As few moving parts in the software as you can possibly get away with. Lastly, if you need code comments, you've done something wrong. Now, this isn't always true. There may be a few cases where you need to really put in some comments to illustrate a really hard concept. But frankly, most of us aren't writing the PageRank algorithm. Most of us aren't writing shortest path algorithms or anything that has that much complexity. And unless you have that kind of complexity, if you need comments, you've probably done something wrong. You probably have a more fundamental problem that you need to correct in your code so you can make the code self-evident rather than needing a comment to explain why you're doing some crazy thing. Organization structure. Here, we want to make sure to build teams around product. There's a lot of organizations that will try to build teams around horizontal layer or try to build teams around kind of division reporting or some other structure. And as you can see, a lot of organizations do this a lot of different ways. But I think the correct way to do this is around product and have a cross-functional team that wholly focuses on the product. The more VPs are required to make a decision, the slower you will be. This will affect your RPM because every new iteration of continuous delivery requires decisions be made constantly. And if you push that decision-making too far up in the organization, it will slow it down and you won't get the RPM that you need to actually have any kind of velocity. Flatter is better, but you still need, if you have conflict in the decision and the data is conflicting, you still need to have human decision makers need those decisions. Ideally, you push them down as far as you can, but you have at least somebody or an odd-numbered small group, like a group of 3 that can vote on something. Decision velocity needs to be very fast. Decision velocity will ultimately drive product velocity. And then kind of just basic management stuff. Avoid we-they scenarios. This goes for any kind of methodology, but it especially goes for something like this. If you start to have groups that are too isolated from one another that both have to work on a product, you'll start to see this dynamic occur. If you start to see it occur, nip it in the bud, take care of it. It comes down to the hierarchy of needs with lean startups. You start with sound engineering practices, like I talked about, 100% coverage, test-driven development, solid principles, so forth, great engineering. On top of that, you layer agile software development, the idea that you build stories that have user-identifiable business value to them, that when you're done, it actually means you've done something all the way from the user interface all the way back to the back-end system. That's the granularity of stories. It's really important because we're building out features that have to go out story by story. And if you only have a back-end piece done and not the whole thing that a user would recognize as value, how do you measure that? There's no way to measure that. So you have to have agile software development. And a lot of these methodologies are based on agile. Continuous delivery. If you're not going to production regularly, there's no way you can test what you've sent out there. If you're not going to production regularly, how do you measure the effectiveness of your change? what will happen is you'll start to batch a bunch of changes in, and you come out with a release every 3 months that has 45 changes. How do you isolate and do a root cause analysis when you have 45 changes that went out with a release? How do you know what drove down conversion? Suddenly you stop being driven by data because you don't have it, and it starts to become everybody's opinion. Well, maybe the color on the screen was wrong, or maybe the button was the wrong size, and you can get into arguments and committee meetings for weeks trying to figure out what happened. On that pyramid, that's what lean startups are based on. It requires everything all the way down to from continuous delivery, agile, and sound engineering practices to actually do this correctly. Further reading. The 3 books I recommend to learn more about this are The 4 Steps to Epiphany by Steve Blank. A lot of that writing influenced The Lean Startup by Eric Ries. And as well, we recommend our own continuous delivery because that is kind of the guide to how you build this engine behind what a lean startup does.